probably try to line these up. Nicole, if I screw these up, you let me know.
This one. Second page one. No, it's not 9585.
If you were working this stuff by hand, notice in a pre-test, post-test, it's just one group tested twice. So what I tried to mimic on this was the independent t-test had a control group and experimental group. So now Dr. Harry Bob is going to test his physical therapy. And basically he did pre-test, post-test on the bin. And so as you can see, some people improved and some didn't. And so the idea is this a significant improvement or not? Remember what that is? Null hypothesis. So there's going to be no differences. Between pre-test and post-test scores. So the assumption is the treatment's not going to be effective. It's not going to go up. It's not going to go down. And as usual, the independent dependent variable. Dependent variable is the bin test score. The independent variable is the Harry Bob treatment.
Is a null hypothesis always assuming that there's no difference?
Always. So as soon as you see that, you'll start shaking your head, no differences. And if you write that, you at least got a point. You can put it in the context of the scenario. You have 2 points. It is kind of our philosophy of science. Like there'll be light. Biology, is that coming on?
It's blinking.
It's almost there. It's like the shadowy forms I saw last night.
Like what?
Shadowy forms I saw in my apartment. So if you don't have your little cheat sheet with you, I'll tell you that a row, regardless, is always a subject. And so this is subject number 1. So basically we'll have 2 columns for the pair sample t-test. So if we enter those columns, I can have a point name. Okay, nothing is happening. It would help if I put the number lock on. There it goes, Nicole. Kara, how's it going today? I don't really care. I want you to know that.
I think you missed the first couple. Or the first one.
Mom. Didn't like me again. how to name your variables. You go down at the bottom, variable view. And I'm just going to call that test. Test. First one you got yours for time? Is that the National
Sarcasm Society.
Oh, excellent. That's the right answer. Brandon, you got yours?
My computer won't even like unlock, so I'm just watching.
Okay. You're in the spectator plate.
Yeah.
Clint, did you get yours going? You getting married this weekend? Following weekend. Cole, is that yours? Tara? Desiree? You have a bow in your hair. She's got a bow in her hair. So, as usual, what I want to do is analyze frigging data. So we're going to analyze, and once we click that, the only thing we're doing is comparing means. For the next two exams, we're just comparing means. And so here we go. And so, which statistical test we got? Paired samples. One group tested twice. So we go over there, paired samples, punch, and they want you to put in the pair. So that'll be the pre and post. Now it doesn't really matter which one you put in first. It'll change the sign. So I use it in t-test. I ignore the sign and I look at the means to make the interpretation. It's the only way you can do it. What? Oh. So you ready? Whitney, you got this ready? Okay. Punch. Zoom. Pow. Pop. Zop. Whoa. There we go. We have nothing else to do. So we have pre, post, mean, bin. And since it's really, really slow, we'll just say 70, 75, 80, 85, 90. So the pre-test was 80 rather, approximately. Post was almost 90. And so there's the magnitude of the difference. And so where do we go first? We go down here and look at our t value. And we're looking here. This is two-tailed tests. Could have made it worse. So is it statistically significant or not? Remember, if that two-tailed is less than 0.05, .05 is here. So we got, what was it, something? 0.25, I forget. So the probability of getting that difference way out there is really, really slim. That says 2-1, doesn't it? So the first place you look is the two-tailed significance. If it's smaller than 0.05, we can say there is a difference. And when you look here, if it's significant, then that means the post-test people scores were higher than the pre-test. So in essence, we assume that they improved. So how are we going to write it in the correct format? T, degrees of freedom is what? 11 equals negative 2.68. Comma, you leave the comma out, you're in big trouble. 0.021.
Where'd you get the 11? Is it just
Degrees of freedom? DF.
N minus 1.
Oh,
Degrees of freedom, when you got one group, remember it's just N minus 1.
oh yeah, okay.
So technically it's the number of pairs of scores, and sometimes it's not about people, but same thing. So how many of you are lost so far? Taylor, you got wrinkle head going there.
I messed up on mine.
Here we go.
You're going to reject or accept the null? Reject. Because the null says there's no differences. We say negatory big bird, there are. Probability of that is so low, so we're going to have to say the treatment really works. So we can, in stat world, reject the null, conclude that the Harry Bob treatment improves significantly Morrison, you got that? Remember, you're supposed to answer every freaking question today.
I know, you haven't called on me yet though.
I know, I see. All right. So usually when we write that, when we say that, once we get here, we're actually putting in there the statistical result.
That's the answer to number 2.
I'm sorry, what?
That's the answer to number 2 on the paper. What is the null hypothesis?
Yeah, the null hypothesis is this.
So
Who
what is
asked that?
I did.
Oh, okay.
So what is this?
This is the results.
Number 10.
So I know he
We wrote it in the correct format and we interpreted the results.
What do you have written under significantly?
Improves significantly, then test scores. That was the dependent variable.
Oh.
Say it again. What?
The dependent variable.
It was the then test scores.
And concluded that the Harry Bob treatment improved significantly.
It's written on here as the motor index score for physical therapy. If they score high, they make even better movements, that sort of thing. Yep. In this case, it's the Harry Bob treatment. He developed something, so we are testing it. On the one before, it was a Zappa treatment and did something differently. So, Sorsen, what are we supposed to calculate now?
Effect size.
Sorsen, so what are we supposed to calculate now?
The effect size.
The effect size, very good, excellent. The exciting omega squared. T squared minus 1 over T squared plus the degrees of freedom plus 1. T is 2.68. Basically, you're just going to get rid of the negative sign. Negative 2.68. Square that. Degrees of freedom is still 11 plus 1 equals. Biology, this is where you're supposed to get really, really excited here. Really excited.
Oh my god, I'm so excited.
I know. It's probably for the wrong reason. That's okay. So I got 6.18 on B for there. So plus 12. 19 plus 18. 6.18 divided by 1 equals.
Here, I'm gonna write this down for you so you have it when you need it.
This is so much fun. Brandon, you doing okay today? Whitney, how's it going now? You getting married this weekend? Any major surgeries, depressions, getting thoroughly snockered? Good. Cindy, you got this? So you and Francis, what the hell does that .32 mean?
I got it as far as up to there.
You got as far
How
as
about
up
that?
to
Wait, I'm not quite sure.